All right, hello. Today we're going to be reviewing chapters 1 and 2 and getting ready for the final. And I'm going to focus actually mostly on DeMorgan's Law because I feel like this chapter for the most part is pretty straightforward. But that'll be the main focus of this lesson. All right, before we get into it, I'm just going to mix in some random review things. So chapter 5 was about methods. And so you have to imagine that you're inside of main and you're calling some method. Maybe I should name this other one something different down here. Maybe I'll change this quick to be other method or something so it's a little less confusing. So we have some method and then other method. Okay, and so we are calling them like this in main. So what would the headings have to look like? Throughout this video, what would the headings have to look like? Public, static, whatever stuff. So throughout this, I would encourage you to pause the video and try the question. So I'll ask you to do that here before unpausing to see the solutions. Okay, so they're going to start public, static, and then the return type. So if you look at this, it's returning to main an int and storing an output. So our method has to have int here for the return type. The name has to be some method. Okay, and then it's going to look like it's going to take in two strings. Okay, so I'm going to do string, and you can name them whatever you want. Sorry, my computer glitched there for a second. So string 1, comma, and then string 2. Okay, and so then the way this works is you'll pass in strings, and then these string 1 and string 2 will take on the values of whatever you send into the method. All right, and then you can use them in the method, string 1 and string 2, do whatever you want with them. Okay, second one is an example of a void method because nothing's being returned. There's no equal and being returned and stored. So when I do this heading, I'm going to start the same way, public, static, but then I'm not going to have a return type. So I'm just going to have void. Usually this means the method is going to print something out generally. All right, and then I'm going to use the name, so other method, and then the inputs are separated here by a comma. So I'm going to the first type must be a double. And you can call it whatever you want. And then the second one must be a string, right? So I'm going to do comma, string, and then give that a name, right? And again, these are the two names I'm going to use to reference in my method. So these end up sort of being local variables inside of this method that can be referenced and used. Okay, so it must take in a double and then a string. All right, so like I said, we're going to focus on DeMorgan Law. And then there's also like this distributive property law that was in here, but we're just going to review these real quick, getting ready for the test. Okay, so just a quick reminder of how this works is you can do like, if you have two statements A and B, there's 4 possibilities. They both can be true, and then A true, B false, A false, B true, or both of them false. Okay, so if you and those together, it means in order for A and B to be true, both A and B have to be true. Okay, so if either one is false, then A and B is false. All right, or just think about what it means. So this means if we did the or truth table, it would be A or B. So either one can be true, and the whole statement is true. So if either A or B is true, the whole thing is true. So the only time that's false is if they're both false. Okay, and then remember this exclamation point just means not, so that just flips whatever it was previously. So true flips to false, false flips to true. And that's helpful on some of these DeMorgan laws, especially if you're in a jam. These tables take a little bit of time to make, but if you get stuck, they're a good option. Okay, so here's a good example of like a sample AP question where a truth table might be helpful. So it says, when does this statement evaluate to false? So when is not A or not B false? Okay, so what I kind of recommend is making the truth table. All right, so basically draw out something like this and then put in our 4 cases for A and B. So we have true, 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 false, false, true, and then both false. Okay, and then build the little pieces you need to make this statement. So I'm going to have to pause the video and try it. If you are unsure, you could watch kind of the next step and then go from there. So when I build the pieces, I need not A and I need not B. So I'm going to build those next. And then after that, then I'll be able to OR them together. Once I have those little pieces, then I'll be able to OR not A and not B. Sorry for that poor handwriting there. Not A, I just flip all the A columns. So I'm going to change all the truth values. Any true gets switched to false and vice versa. For the B, again, just switch them. So if it's true, it becomes false. If it's false, it becomes true. Okay, and now just OR these together. So either one can be true. So it looks like this. Okay, so when does it evaluate to false? So it only evaluates to false in the first case. Okay, so it evaluates to false when both A and B are true, which kind of makes sense because that would be not A or not B, right? That's only going to be false if both of them are originally true. So when does it evaluate to false? When both A and B are true originally. Normally there'll be some sort of multiple choice on that. Okay, so that was a little bit about truth tables, and then DeMorgan Law, just a reminder, it's basically like you distribute in the not. If you have a not on the outside of a parenthesis, you can distribute it and then change the symbol between it to be or. So it's equivalent. This not A and B is equivalent to not A or not B. All right, and similarly, if you have an or between them, distribute the not and then switch it to an and. Please know that these questions, sometimes you have to go both ways. So like normally I would do this distributive here, but you could also pull the not to the front and switch it to an and, right? So you kind of got to be able to go both ways on some of these questions. Okay, so just a few ones to kind of review with you. I want to know what are the equivalent of these using DeMorgan. So pause the video and give these a shot. Okay, so I'm going to distribute the not. So this one would be not South Dakota, change the sign between them, and not North Dakota. So anything that's not in the Dakotas. Here's the one we're going to pull it to the front. So the not gets pulled to the front. So I'm going to do not and then male and tall because I got to switch the sign between them. So pull it to the front, change it to and switch the signs between them. Last example here, same thing. I'm going to pull the not to the front and then I'm going to switch it to an or. So glasses or piercings, like that. Okay, just a couple examples using DeMorgan. The other property we learned kind of related to DeMorgan's law is if you have like an or on the outside, you can distribute that or in and make it into two statements like this, right? So the A or gets distributed with both the B and the C. Similar to an and, you can distribute that in. All right, so I'm going to see if you can apply that to these two ones down here. Pause the video, give it a shot. Okay, here are your answers. So the male is going to get distributed here. So that statement on the left is equivalent to male and glasses, if I can spell it right, or male and tall. All right, so just distribute the male and. Here we're going to reverse, we're going to pull it to the front. So we have smart and, so I'm going to do smart and then in parentheses, I'm going to do junior or sophomore. Obviously, everyone knows that it never evaluates to true. Smart and junior or sophomore. Okay, so that's just kind of the reversing property, pulling the smart and to the front. All right, so just want to do a couple sample AP questions. There will be AP level questions on the final, so I want to make sure I mix them in here. Yeah, so on this one, my hint would be start on the inside and work your way out and try and figure out which one of these is equivalent. Use sort of the properties we were just talking about. All right, so the first thing I would notice on this one is this is really redundant. I'm going to do not A not equal to B. That is the same thing as wanting A to be equal to B. So I'm just going to change that to A equal B. Because the opposite of being not equal would be equal. Okay, and then we still have the and B greater than 7. All right, and now it's DeMorgan, right? Because now I can distribute this not inside of here to do not both of these and then switch it to an or. So I'm going to do A not equal to B, or, and then this gets a little bit reverse goofy, but the reverse of being greater than 7 would be, you might think it'd be like less than 7, but I think the right thing here is actually less than or equal to, because the opposite of being greater than 7 would be less than or equal to 7. So when we distribute the not, I just reverse both of these. So this becomes not equal again, and this one becomes b less than or equal to 7, which I believe gets you this one, right? Letter B. So I probably should add the parentheses there. All right, one more for you to try. This is more of the distributive one. Okay, so basically this is y greater than 10,000 or this and statement. So this is going to be distributed in, that or is going to be distributed in with both of them. So we want y greater than or equal to 10,000 or x greater than 1,000 and y greater than 10,000 or x less than 1,500, right? And so with the right parentheses and everything, I believe that's letter A, right? We just distribute that or statement with these two and keep the and in B between them. All right, that's it for our review of chapters 1 and 2. Again, it's mostly about these truth tables. And there's really sort of two properties again, the DeMorgan Law, which has the not on the outside, and then this distributive property, which is kind of 3 statements, right? 1, 2, 3, and you distribute the one statement on the outside into the other two. Another hint too is if you get in trouble, think about a truth table, right? If you really have no idea, I know they take some time to make, but if you're really stuck, a truth table sometimes can get you unstuck, like we did on that early question in this review. All right, that is it. Thank you for watching.